Good afternoon, everyone. As Alistair mentioned, my name is Cristina Agafon. I am currently the customer success lead and also a senior hydraulic modeler and hydrologist. And I've been carrying the pain of working with confusing and frustrating spreadsheets for about 9 years now. I will have the pleasure of showing you a better and safer approach to undertaking your hydrology analysis. So welcome to the Hydrology Essentials from Theory to Practice webinar. Today, we'll be diving into some exciting topics in the field of hydrology. We'll start with a high-level overview of the current practices and methodologies which are used in the UK for hydrological analysis. Next, we'll explore the capabilities of Flood Modeller's Hydrology Plus module. We'll discuss how it integrates with industry standard practices and how it enhances our ability to model and analyze flood events. We'll then move on to a live presentation of the software, where I will be showcasing its features and functionalities in real time. This will give you a practical understanding on how to use the tool effectively. And finally, we'll open the floor for questions. So let's get started. The hydrological analysis in the UK is quite complex and also fast evolving. If I may, I'd like to share a memorable phrase from the Environment Agency Flood Estimation Guidance, which says, if you think it's easy, you're not looking deep enough. While many flood estimation methods can be applied using straightforward software and freely available data, the process itself is complex and it involves numerous aspects. The flood estimation methods can be categorized into two main approaches. The first one would be the statistical method, which relies on historical river flow data, which spans over several decades to predict peak flows during extreme events. While the second approach is the rainfall runoff, a conceptual catchment modeling method, which generates designed flood hydrographs based on estimates of extreme rainfall. In the UK, the standard practice for deriving flood hydrology involves using the ReFH methodology and its updates with the WINFAP and ReFH2 excuse me, hydrology software packages, which have been developed by Wallingford Hydro Solutions. These solutions have received approval from the Environment Agency, the Scottish Environment Protection Agency, Natural Resources Wales, and the Department for Infrastructure Northern Ireland. The statistical analysis approach outputs peak flow estimates, while the rainfall runoff generates a hydrograph, so a time series. Consequently, these methods are often combined to take advantage of each other's strengths. Several organizations, including the ones I just mentioned, offer extensive guidance on hydrological analysis. It is highly recommended to consult these resources before embarking on either the statistical or rainfall runoff methods. WHS, with whom we have built a strong relationship and excelled in teamwork to bring you Hydrology Plus, provide reference materials, help documents, as well as training sessions for their industry standard software, WINFAP and ReFH2. So WINFAP provides a user-friendly digital platform for conducting statistical analysis on both gauged and ungauged catchments. For ungauged catchments, you'll need to purchase the necessary data catchment descriptors from ReFH online. As there are many approaches on undertaking a statistical analysis, the one I am interested for this webinar is creating a new pooling group for my site. So we will see that in the live demo. This involves selecting relevant gauging stations to form a group that meets the required criteria. For example, having a sufficient number of years of data, the 500 years being the default. I will examine the pooling group for any outliers or inconsistencies. You can conduct a QMED analysis to estimate the peak flow at your site. And you can use observed flow data from the selected pooling group. You can also check the homogeneity. You can verify that the pooling group is homogeneous, meaning that the selected stations within the pooling group have similar hydrological characteristics. And then you can save your document save and document your analysis, so you can save this analysis now in Flood Modeller as well. ReFH2 is a rainfall runoff model which is used to generate the flood hydrograph. The software will simulate the runoff response of the catchment to the input rainfall data. You will need to load your site catchment descriptors, including the DDF parameters. So these are the depth, duration, frequency parameters, which are sometimes provided by the client, but nowadays are purchased from FEH online. You can then set the initial conditions for the catchment, such as soil moisture deficit, and you can also adjust other relevant parameters. So, how does Flood Modeller fit within this hydrological analysis? Well, the Hydrology Plus module introduces an innovative database which is designed to consolidate hydrological data and analysis in a single, secure, and consistent environment. This database is installed on your computer as part of the Flood Modeller software, and it operates as an SQL database service. To ensure optimal performance, the database is stored locally on your computer, which is recommended to back up regularly. It stores hydrometric data from the UK gauges and FEH catchment descriptors, which users have imported from FEH Online. Flood Modeller provides a digital workflow for undertaking methods for the Flood Estimation Handbook, so FEH, but users should have a solid understanding of technical and regulatory requirements before undertaking the analysis. So after you have created a Hydrology Plus project, you can import and manage FEH catchment descriptors. You can perform hydrological analysis by opening WINFAP and ReFH2 from within the Flood Modeller UI. So WINFAP and ReFH2 will have to be installed on your machine separately. You can undertake the FEH reconciliation by applying scaling factors to your hydrographs, whether these are calculated by the tool. So you might have to choose the approach to scale the ReFH peak flows to your WINFAP derived peak flows, or this can be provided by the users. All your work is saved into one place. So that will be the Hydrology Plus project. And you will not have multiple versions of spreadsheets, which will make your experience more pleasant, having one location only. And it will also remove the burden of tracking down which file is the latest in a folder with N files with the word final in its name. You can export the output of your hydrological analysis as a CSV file, which can then be used directly into a Flood Modeller 1D simulation file. So I guess enough with the words, and I will start now the live demo. Hopefully everything will be fine and I will not be hit by the live demo karma. So let's jump in. As you might be familiar with, this is the Flood Modeller user interface. I have already loaded a 1D river network, and we are located in Upton upon Severn, so this would be the Severn River. It is a model which is used for webinars quite often, so you might be familiar with it. I've also prepared a 1D simulation file where I have loaded my 1D river network, but I do not have any flow time series data because this is what I will have to prepare now. So the new model, Hydrology Plus, has its own tab. Under this tab, you can create a new Hydrology Plus project, or you can open an existing one. What I will do is I will create a new Hydrology Plus project. So if I click on new, I can give it a name, Upton Hydrology. I can give it a project reference number, and I can also add a description. You'll have to click OK, but I will cancel this because I have already created a Hydrology Plus project, so I will show you the project details of this project. So I've added a description. I said that I am creating design flows for the upstream and lateral inflow points of the 1D river network, which is covering the Upon Severn village. Under the Hydrology Plus tab, you can add river stations. So you can add all river stations, or you can select if you want to see only the level or the flow ones. So these are river stations that are managed by the Environment Agency as well as SEPA. If I will click on a gauge station, which is suitable for pooling and suitable for QMED, I can automatically create a calculation point. So this is a flow estimation point. So it will extract the catchment descriptors which have been saved with by CEH. So I can conduct a hydrological analysis at these locations. I can hide all of them, and I could also plot all the CEH, so the NRFA gauge stations. And again, if I will click on one of them, it will be highlighted. This window will pop up again, and I can either view the full info or create a calculation point, so flow estimation point. If I click on view info, I will have the site description, observed data. This will take just a couple of seconds to load. I can zoom in and zoom out in the available data, but I can also change the range of flows the range of times for the flows that I want to view on this plot. I can also export the boundary. So if I will zoom in on one of the peaks in here, it will now load 15 minutes data. So if you are selecting 8 weeks or less of data, you will be able to export 15 minutes boundary. You can save it as either a flow time boundary, a CSV file, or calibration file. You can save it as a calibration file and use a relative data for the time. And then you can use this calibration file in order to calibrate your 1D river model to different locations within your river network where you have gauges with observed data. So I will cancel this. So for this live demonstration, what I will do is I will create some calculation points at which I will undertake a hydrological analysis, results which I will then use as an input into my 1D river network. So I will hide all the gauging stations as I am not interested in them at the moment. My catchments are engaged, so I have two input inflow boundaries in my 1D river network. These are both engaged, meaning that I will have to import the catchment descriptors. So these catchment descriptors can be bought from FEH Online. So if you click on the download button, then the web FEH will have to open, you will have to log in, and you'll have the map of Great Britain in my case. I have already bought these catchment descriptors and I have exported the information that I need. So I have here the upstream catchment of my 1D river network. And what I will need is the boundary shapefile, which will be exported as a zip file, and the descriptors with the XML format. I will have to save them both in the same folder. So I have already saved mine in a folder called FEH. So I have my zip files, which I will leave them as they are in this folder with the catchment boundary, the shape files for the catchment boundaries. And I also have the catchment descriptors saved in an XML format. What I will do now is I will import these FEH boundaries. So if I will click on import, I will again click on add files, and I will select these two files to be imported into my Hydrology Plus project. I will open them, and I will also get a message saying that the boundary shapefile has been found. And then if I click OK, I already have these catchments imported, but that should be fine. And if I click on View Catchments, I will then have these catchments on my map view. I will now want to calculate flood estimation points for these two catchments. So I will start with my upstream catchment. I will highlight it, right-click, and create a calculation point. In this window, I can give it a calculation. I can give the calculation point a name. So I will choose to call it the same as my upstream boundary, which is SEV 10583. I can give it a description. So I will just say that is flood estimation point at the upstream of my 1D river network. You can add some comments as well. The basin location has been selected automatically, and it shows as Wales because this is where the catchment is starting in Wales, but I can show you later on that you can actually modify the basin locations when you are starting to do your FEH reconciliation. And if I click OK, I will now see that a calculation point has been added on the map view. If I highlight it and right-click, I can go into the calculation point properties. So this is where I will be undertaking my hydrological analysis. I have the details which I've added initially when I created the calculation point. I have the catchment descriptors that I have imported. I have here the option of updating these catchment descriptors. So I have in the right-hand side the preferred version. I only have one version at the moment because I haven't updated any catchment descriptors, but I can easily do so in this table. So for example, let's update the area. Let's say that we have a 6830 square kilometers, and this has been the result of a watershed analysis. So I can also add comment to help understand why understand and follow up on why this area has been updated. I will also change urbex. So let's say that the urbanization has increased, and I will add here a comment saying that factor was updated following 2024 year. Factor was updated following 2024 year, applied in formula. If I will click Save, a new version will be saved in here, and it will be defaulted as the preferred version. You can also add a comment in here, so I will just say that area and urbex have been updated. Save, and now I have version 2 as the latest. Just keep in mind that whichever version you have selected in here as the preferred version will be used when you will initiate a new ReFH2 or WINFAP analysis. So I will leave preferred version 1. I will go into the ReFH2 tab and I will initiate a new analysis. This will open the ReFH2 software. Should happen anytime now. It has already loaded the catchment descriptors. I'll just go next. So just for time saving, I will go next. I will not make any updates for this example. I will just save, but you can make the updates. You can change model parameters or urbanization. So it will be an ReFH2 analysis. I will save, and then I will exit to Flood Modeller. In the pop-up window, I can change the name. So I will just leave the name as it is. I will add only default just to make sure that it's obvious that this is using the default catchment descriptors. And I will save. So I now have the plots of the ReFH2 outputs of the time series. I can choose which return period I want to be plotted. I can plot all of them. And I can toggle between urban and rural. So let's say I will now use my updated catchment descriptors. So I went back into catchment descriptors, selected as the preferred version, version 2, and I will initiate a new ReFH2 analysis. Okay, again, I will just go quickly next, save, and I will exit to Flood Modeller. Again, make sure that you do a proper hydrological analysis. So this will be updated and save. I can choose which one I want to be my preferred version. So either the updated one or the default one. For now, it's the updated one. Just for time saving, I will leave the preferred version as the second one, and I will initiate my WINFAP analysis. So now WINFAP will load the catchment descriptors that I have updated within the catchment descriptors tab. It's always slower when I share screen. Okay, so I have the site of interest. If I right click and select the pooled and QMED analysis, this will create a pooling group. You can review your pooling group and also check the goodness of fit and heterogeneity. You can update the list. You can add stations or reject stations. You can check its suitability, and you can also add comments in here. I will just leave the pooling group as it is, and I will save to Flood Modeller. I will exit. And then I will say that it's the default pooling group. I now have the flood frequency curves, and I have plotted all the flood frequency curves that I have pre-selected in WINFAP. So I have GLGV, the distributions GLGV and CAP3. And I also have the current ReFH plotted here so that I can see how they fit with each other. I can either plot the FFC or the growth. I can choose which distributions I want to see on the plot. So either all of them or only one of them. If I have the FFC, it will allow me to show the current ReFH2 analysis as well. So this would be the preferred one under our ReFH2 tab. If I go to my hydrograph library, I will have to add a new hydrograph. So the scaling tool will now pop up. So in here, under the FEH reconciliation, I can choose which version of ReFH2 and WINFAP I want to use for the reconciliation. So I will be using the updated catchment descriptors and the updated catchment descriptors, but with the default pooling group. I can then use, in the hydrograph scaling, I can use the calculated scaling factor by the tool so that I can create time series for my one river network for my simulation. So I will be using the peak flows from the statistical analysis, which will be applied on the ReFH2 peak values. I can also apply climate change. So in here, it defaults to Wales, but if I click on the three dots, I can change the country to England. And now the correct climate change uplift will be selected. I'll just go with the higher, 2020 is higher, 2050 is higher, as well as 2080 is higher. And again, I can play with the chart, and I can either plot all of the return periods or the one that I want to focus on. And I can save the hydrograph. I can have a list of multiple hydrographs in here, depending on my scaling factors as well. If I chose to use my own scaling factors and not the ones calculated by the tool, I can view the hydrograph again. And I can also export the hydrograph. So this will be a CSV file, which I will save under my AFH folder. After I have completed my ReFH analysis and my WINFAP analysis, I have created my time series by undertaking the FEH reconciliation. I can now close this calculation point. I can always go back to it. So if I will highlight it, right click and go into calculation point properties, I can go through each of the tabs again. I have already created a calculation point for my lateral tributary, so I follow the same process. And now I want to use the exported file, the CSV file, as an input into my 1D simulation file. So if I double click on my 1D simulation file, I can add the flow time series data in here. So I have my upstream input and my lateral input. For my upstream input, I can choose from the drop-down menu which return period I want to use. Let's go with 100. If I have different storm durations, again, I can choose which one I want to use. In terms of the epoch factor, again, it gives you the option to choose which one to use. And if you click on the three dots, it will pick up all the node labels where you can apply this, this time series. So we will select the one at the top, SEV, click OK. And then I will also add my second boundary, which is the lateral one. I will use the same return period, and I will choose the lateral opt-in label. I can then save and run. So yeah, my simulation is running. I can review results and so on. And the Hydrology Plus project is saved automatically, so you do not have to worry about that. So we have the Hydrology Plus report builder coming next, which generates components for the hydrology reporting. You have consistent outputs tailored to the FEH proforma. You have plots, tables, WINFAP, and ReFH outputs, and it automates the report production. And then we also have the Hydrology Plus Sim Builder, so you can use the CSV files that you have created during your Hydrology Plus analysis within the simulation builder, and you can create your simulation files much quicker. So it's just using a matrix.